Similar to a clock, the human body relies on a number of separate parts, working together in order to run well. If one part is not functioning properly, the other parts can be negatively affected.
Alright. And for some reason, they updated AES website so it looks funny. So if I'm struggling, it's because I'm not used to this. Because stuff is not where it was. I've been using this for like 3 years and now it looks so different.
This module will give you an introduction to the human body. You will define anatomy and physiology.
So like when y'all get ready to start your portfolio portion, like this will be like, before each section we have this little slide that says you'll be able to, those are your objectives. So that, not this one though. For skeletal system, I'm just showing y'all where it's gonna, like how it's gonna look. So like if you go on the AS website, you want to go ahead and write your objectives down. Then as you go to each lesson, it has this slide before we actually get started with the notes that has, you'll be able to, after you finish this lesson, you'll be able to. So those are your objectives.
Let's define the terms anatomy and physiology. Do you know where your lymph nodes are? What about your uvula? If not, anatomy can help you. Anatomy is the study of an organism's body structures and their locations. Your nose helps you to breathe, and it also allows you to smell. Like the nose, each part of your body has a purpose. Physiology is the study of the functions of each body part.
All right. So there's a lot of things y'all probably don't know where it is in the body, but you will learn a little bit in this class. Hopefully, if y'all pay attention. All right, so your lymph nodes are those things that, like, they're all over your body. You just don't know it. They're in your neck. They're under your arms. They're in your groin. Those are the like little nodes that swell when you have an infection in your body. So when your doctor checks your neck and stuff, they're looking for lymph nodes to see if they're swollen. Y'all haven't got to this step yet, but when you get older and start having females have to do like breast exams for checking for like tumors and stuff for breast cancer. You check your arms too because you're looking to see if any lymph nodes are swollen. So those are places, like if a lymph node is swollen, people think it's a lot of times a sign of something, like, so they swell in response to your immune system being attacked. So like when you have a temperature, um that's something that says, okay, something's going on because your body is responding to whatever that pathogen is, whatever that's trying to get in, that's in your body. That's a reaction. So your lymph nodes will swell. You might spike a temperature. So that's like how they were really big about taking temperatures with COVID because that's a sign that something's going on. But I mean, you can get a temperature or anything. But anyway, so that's what lymph nodes are. And they're also like can be behind your ears. They're like in your neck. They're like up here in your groin, under your arm. I'm sure I'm missing some spot, but normally when you go to the doctor, they might like check behind your ear and check like here to see if anything's swollen. Especially if you come and say like you're having these type of symptoms, they might check it, see if any of your lymph nodes are swollen. Then blood work also to see your white blood cell count is out of whack, because that's like white blood cells are have to do with like your immune system. All right, so we're gonna look at. All right, so we're gonna look at to determine what we're looking at if it's either just consider anatomy or physiology. Okay, so upper airway begins in the nose and mouth. What is that? Is that anatomy or is that physiology? Anatomy. Heart helps to deliver oxygen and nutrients to cells. Liver sits to the right of the stomach. Epiglottis is inside the pharynx. A cell takes in food and oxygen. Physiology. Kidneys filter and remove waste products from the body's bloodstream. Right.
Now that you understand what anatomy and physiology are, we can move on to why it should be important to you. Have you ever encountered a so-called professional who had absolutely no idea what they were talking about? If you have, then you know it can be terribly frustrating when the person helping you is not knowledgeable in your area of need. In this lesson, you will determine the reasons anatomy and physiology are important to healthcare workers.
All right, so it's important as healthcare workers, people that work in healthcare, to know, you know, about anatomy and physiology of the body. However, they don't know everything. I mean, just because they're a doctor doesn't mean they know everything. So you got some doctors that might be just like general practice doctors. You might have something going on with your heart, so they'll refer you to a cardiologist because that's not their specialty. You might have seizures or something going on with your brain. They'll refer you to a neurologist because they specialize in uh stuff like that, like seizures, brain issues, strokes. Like if you have a stroke that affects your brain, stuff like that. So they don't know everything. So that's why it's important, like, to make sure you get to the right people for the right stuff. Because if you just go to your general doctor, they know stuff, but they don't specialize in just like one thing. These cardiologists, all they do is look at the heart and how it works and diseases, disorders. Neurologists, they study the brain and know what brain waves mean. They know this, so that's, you have to get to the right people in order to sometimes to get treated.
So I was wondering, why do I need to learn this anatomy and physiology stuff anyway? I decided to take matters into my own hands and to ask three healthcare professionals just that. Why is it important to you, as a healthcare professional, to have knowledge of anatomy and physiology?
Anatomy and physiology makes a difference between me being a nurse and me being a great nurse. So part of what I want to do as a brain is that you can anticipate problems and do those interventions before your problems really occur. And my ability to apply A&P is what makes me a difference.
And not only nurses, but techs and aides and pretty much everyone taking care of patients. Anatomy and physiology is going to tell you about how the body works. It's going to tell you about the muscles and the bones and the blood and all of the chemicals going on and how the brain functions. And while it seems like a ton of information and sometimes tedious information, it is so important to knowing what's going on for your patient.
I've worked at hospitals, nursing homes, I've worked in the mental health field, I've worked in a doctor's office. And in each one of these cases, without anatomy and physiology, I pretty much would not have known what I was doing.
In my role, I'm assessing for problems that mama baby is running into during the labor process, and then I'm doing interventions that address those issues or correct those problems. So, for example, if a baby's heart rate drops, one thing that I would do is to her mom on her side. And what that does is it changes the amount of venous return to mom's heart, and by extension, increases her cardiac output.
And when your patient's family members ask you questions about why their grandpa is on a certain heart medication, you can tell them how the blood's flowing through the heart and how the heart is pumping, how the muscles are working, how the electrical system of the heart is working.
I also worked as a surgical scheduler, which involved radiology scheduling as well as interventional radiology. Now, how it helped there, it was a different way I used it. I was able to know when offices or patients come to schedule these things, in particular, why they were doing it. And if they needed a certain procedure, why the procedure was needed. It even helps with coding, knowing kind of where to aim for with coding.
You know, we're people, and you can only see the outside of people. You can see their eyes and their nose and their arms, and they can tell you that they have pains in those areas of their body, or they can tell you that they just don't feel right. But if you know what's going on inside the body and what the muscles look like and what those little parts of the body look like and how they're functioning together, then you have some real clues as to what is going on for your patients and maybe how to make them feel better. And isn't that the goal for everybody?
Just kind of hear me out, guys. I remember what it's like to be in those courses, and it is completely tedious and very overwhelming. And there's 101 things that you're supposed to memorize, wrap your head around, and things that you're just surely never going to need. And some of it you won't, to be honest. Some of it will fall by the wayside, and you won't ever remember it past the exam. But some of it is going to change the way that you do your jobs. It's going to change the kind of employee you are and the kind of professional that you are. And it's going to change, honestly, people's lives, the way that you take care of them, whatever facet that you're going to be doing that.
You've heard from some of your future peers. Knowing the basics of anatomy and physiology can help you be a rock star in the healthcare field.
So, although you might not know everything about the anatomy and physiology of the heart or of the body, you'll learn, you'll still learn. So I still was learning when I worked at the hospital about how stuff works. But I'm one of those like hands-on people, so I learned it in school, but it didn't make sense, so I actually saw it or was able to do it or whatever. So, it's being in medicine or in healthcare field is always like a learning process. It's always room to learn more things. So, all right, so we're gonna talk about or look at like how things are formed. So we're gonna look at like cells, um, basis of body structure, and all that.
Take a look at all of the plants and animals here on the screen. What do they have in common? They are all made up of the same basic building block, the cell. In this lesson, you will define what a cell is, describe the functions of cells, and identify the parts of a cell. The human body has 6 levels of structural organization. The first level is the chemical level. In order to build a cell, you must start with a molecule. Molecules form when 2 or more atoms form chemical bonds with each other. DNA is an example of a molecule. Molecules are organized into cells. Let's learn more about cells. So what is a cell? Cells are the smallest structural unit of living things. All living things, including you, are made up of cells. There are trillions of cells in the human body, but most of them are so small you can't see them without a microscope. Though they are microscopic, they vary in shape and size. Cells carry on all of the functions of life, such as taking in food and oxygen, producing heat and energy, eliminating wastes, and reproducing to create new cells. Different types of cells perform different functions.
All right, so which of the following best describe cells? Smallest structural unit of living things. So anything that's alive, us included, uh, are made up of cells, like billions of cells. Oh. All right, so which of these are functions that cells perform? Hmm? Anything else? No, not all. Anything else? Huh? So taking in food and oxygen, producing heat and energy, reproducing to create new cells are all functions that cells perform.
Now that we've discussed what a cell is, let's see if you can put the 3 main parts of human cells together. Drag the cell membrane to the right to begin building the cell.
So which one is the cell membrane?
The cell membrane forms an outer boundary around the cell to separate it from its surroundings. This thin membrane is also known as the plasma membrane. It is semi-permeable, which means that it allows certain substances to enter and leave the cell while it prevents others from passing through. Drag the cytoplasm to continue building the cell. Cytoplasm is a jelly-like semi-fluid material that transports substances within the cell. This is where many chemical reactions take place.
All right, so your cytoplasm, it looks like some jelly, semi-fluid material. It's where your chemical reactions take place.
Drag the nucleus to finish building the cell. The nucleus is a round structure within the cytoplasm. It may be referred to as the brain of the cell because it controls cell activities and directs cell reproduction. It is surrounded by the nuclear membrane.
All right, so you have your three parts to the cell. So you have your nucleus, you have your cytoplasm, and then you have your cell membrane.
You now know that the cytoplasm is one of the three main parts. Cytoplasm contains many small structures. These structures, including the nucleus, are called organelles. Organelles have the specific job of helping the cell to function. Drag each organelle under the microscope to find out what it does.
All right, so let's look at this.
Mitochondria break down nutrients to help make the major energy source for the cell, adenosine triphosphate, ATP. They are often referred to as the powerhouse of the cell.
So that's your mitochondria.
The centrioles play an important role in cell division. They exist in a single pair in the centrosome in each cell, which is located near the nucleus.
So these are your centrioles. Yes.
A vacuole is a space within a cell, somewhat like a bubble, that is empty of cytoplasm, lined with a membrane, and filled with fluid. It performs functions such as storage, ingestion, digestion, excretion, and expulsion of excess water.
Okay. So that's your vacuole.
Ribosomes help to create protein. They are made of ribonucleic acid, RNA, and protein, and are produced in a nucleolus, located in the nucleus. Then they move to the cytoplasm, where they may exist freely or attach to the endoplasmic reticulum.
So these are your ribosomes.
The Golgi apparatus is a stack of membrane layers that produces, stores, and packages secretions to be sent out of the cell.
So these are your this is your Golgi apparatus. So it looks like little, I don't know, like layers. If you look right here.
Lysosomes contain enzymes used to digest food as well as other substances. Therefore, they can destroy bacteria and other foreign matter to protect the cell. The endoplasmic reticulum is a fine network of tubular structures that allows substances to be transported into and out of the nucleus. It also helps to make and store proteins.
So this is your endoplasmic reticulum. That moves. All right, so what are organelles? All right. Small structures with a specific job, which is to help the cell to function. All right. What is known as the brain of a cell? So you have your nucleus. All right. I'm gonna tell her where to put this stuff. What is that? Calm down. You're getting excited over here. All right. So what goes where? What's this? What about this? Got it? No. It has a mind of its own. What about this? What's this? Black.
First thing you be doing is doing your reflection, right?
This. Vacuole. What about this? Blue. This. This. And then ER, reticulum. Good.
In this lesson, you defined the term cell, described the functions of cells, and identified the parts of a cell. Now that you've learned about the importance of the cell in the body, it's time to learn about other structures in the body. In this lesson, you will define what tissue, organs, and systems are, distinguish between different types of tissue, identify organs of the body, and organize the levels of the body's structure. As we mentioned earlier, the human body has 6 levels of structural organization. At the chemical level are molecules. Molecules bond together to form cells. Cells differ in shape, size, and function, even though they mostly have the same basic parts. No matter the shape, size, or function, cells remain the building blocks for the rest of the structures in the body. Cells with similar structure and function can join together to create tissue. Tissue joins together to create organs, and organs group together to form organ systems that work together to perform a specific job in the body. All the systems function together to make up the total organism. Since you've already learned about molecules and cells, explore the remaining structures for more information. Tissue is formed when cells of the same type join to perform a common task. There are 4 major groups of tissue. Click each group to view more information.
All right, so you got connective tissue, muscle, epithelial, or nervous tissue.
Nervous tissue carries messages throughout the body to direct its activities. Neurons establish an electrical communication system within the body.
All right, so then you have your epithelial tissue.
Epithelial tissue covers internal and external body structures and forms glands. Epithelial tissue protects your body from moisture loss, bacteria, and internal injury. This tissue covers almost all of your internal and external body surfaces. For example, the outermost layer of your skin and other organs.
So examples of epithelial tissue is your skin. Your skin is it's like a protective covering over, your bones, your organs, your muscles. You have your muscles.
Muscle tissue contracts to support either voluntary or involuntary movement in the body. There are 3 types of muscle tissue. Skeletal muscle supports voluntary movement, such as walking and even maintaining your posture. Cardiac muscle, which is only found in the heart, supports involuntary movement, such as the beating of your heart. And smooth muscle, also involuntary, supports actions, such as food digestion.
All right, so you have different types of muscle tissue. You have cardiac, skeletal, and smooth. Um, Skeletal is voluntary. That means your brain is telling it to move. Then you have your cardiac, and smooth is involuntary, meaning it moves by itself. So cardiac, as we know when we did medical terminology, card is heart. So this is the type of tissue that is found in your heart. So your heart is a muscle that beats. So it contracts and relaxes, contracts and relaxes. That's your heartbeat. So that muscle or that tissue, it doesn't, like, nobody is telling it to contract and relax, contract and relax. That's just, it's involuntary, meaning it does it by itself. And then your smooth muscle, like when you eat and stuff, when you take in food that goes in your esophagus, goes down into your stomach and through your intestine and stuff, it's moving. The muscle is moving it along because it's like involuntary. It's not you're not telling it to do that. It just does it because it's involuntary. It's involuntary movement. And then you have connective tissue.
Connective tissue provides structure and support for the body. In other words, it holds body parts together. There are 6 types of connective tissue. Loose connective tissue connects epithelial tissue to underlying tissue. It also helps stop pathogens from entering the body's bloodstream. Fibrous connective tissue is strong, dense tissue that is used to connect muscle to bone and bone to bone. Adipose tissue, also called fat tissue, serves as an energy stockpile, padding, and thermal insulation for the body. Cartilage, used as a physical shock absorber and reduces friction. The flexible part of your ear and the tip of your nose contain cartilage. Bone provides support and protection, as well as allowing the body to move. Blood serves as the transportation mechanism for important chemicals in the body.
What is formed when cells of the same type join to perform a common task? Alright, so which type tissue holds our body parts together? You got loose fibers, adipose, cartilage, bone, and blood. What's the last one I just went over? Like this. Covers internal, external body surfaces and forms glands. Is the main tissue in the skin and lining of body cavities. Epithelial. Contracts to allow the body to move. And then carries messages throughout the body. Nervous. Alright, so what type of tissue? So look at where it's pointing. What type of tissue is this? Here?
I mean, I'm also nervous.
Nervous. What about this one? What's that? So it's pointing to your skin, pointing to your internal organs. This one pointing to your organs and muscles. Somebody say something? No? And then this one is pointing to like your bones. Alright.
An organ is formed when groups of tissue work together to perform a specific function. Mouse over these familiar organs to learn what function they perform.
So you got different organs. You have your lungs. They deliver oxygen. And remove carbon dioxide from your blood. And then you have your stomach. Stores food, breaks down food with juices secreted by your stomach lining. You have your kidneys. They make urine from waste products and excess water found in your blood. Oh, is Brian up there? Oh, I don't see it. The brain controls your body and houses the mind. Groups of tissues that work together to perform a specific function form a what? Or an what? Organ. Right. Which of these body parts listed below are organs? Heart and brain. Alright, so then you have a system.
An organ system consists of a collection of organs and other body parts that work together to carry out one of the body's major functions. While systems have distinct roles, they do rely on each other. Major body systems include the integumentary system, skeletal system, muscular system, nervous system, sensory system, cardiovascular system, lymphatic system, respiratory system, digestive system, urinary system, endocrine system, and reproductive system. You will learn about each of these systems in this module.
Which we're not going over all of them. We're going over skeletal, muscular, respiratory, cardiovascular, and reproductive. We're not going to have time to go over all of them. An organ system is a collection of organs and other body parts that work together to carry out one of the body's major functions.
An example of an organism whose systems all work together is the human body.
So all these things, molecules, cells, tissues, organ systems, organisms, organ systems that make up an organism, which is our body.
The levels of body structures on the left are all mixed up. Rearrange the items by placing them in the correct position on the right.
All right, so what's the most simple? What's next?
In this lesson, you defined what tissue, organs, and system are, distinguished between different.
All right, and in the last section, we're going to look at diseases and immunity.
Your body is built to automatically protect itself against unpleasant conditions and illness. Have you ever wondered how your body protects itself in the heat or in the cold? Have you ever been around others who were sick, but you managed to stay well? This lesson will help you to understand these functions of the human body. In this lesson, you will define homeostasis and disease, describe abnormal cell conditions, identify types of tumors, and explain types of immunity. The average temperature of the human body is around 98.6 degrees Fahrenheit. So how does the body maintain that temperature when conditions on the outside of the body change? Well, the body regulates its internal conditions through a process called homeostasis. Homeostasis refers to keeping a state of balance in the body. To sustain the same internal environment inside, the body must constantly adjust to outside changes. For example, your body sweats to keep cool in hot weather and shivers to keep warm in cold weather. That's your body regulating itself internally in order to maintain homeostasis. Your body must preserve a balance of fluids, temperature, oxygen, electrolytes, and nutrients for survival. In order to create homeostasis, the systems of the body must all work together. This is called interdependence. Interdependence means that even though each system has a unique function, it must work together with other systems in order to support human life. Click each diagram to find out what systems are working together.
All right, so systems are different. They have different functions and stuff like that, but some of them have to work together.
The endocrine system supplies hormones that direct activities in many other body systems, including the urinary and reproductive systems. The nervous system works together with the sensory system to recognize changes and respond to them. The muscular and skeletal systems work together to produce movement. The cardiovascular system works with the respiratory and digestive systems to supply oxygen and nutrients from outside sources to the cells in the body. Because body systems depend on each other, a problem in one system may have an effect on other systems. Sometimes the treatment for a problem may also involve a number of body systems. Problems within the body are typically described as diseases. Disease is defined as a disorder or incorrectly functioning organ, part, structure, or system of the body. Disease can be the result of the effect of genetic or developmental errors, infection, poisons, nutritional deficiency or imbalance, toxicity, or unfavorable environmental factors.
So these are reasons why people have diseases. So it could be genetic, like diabetes is something that can be hereditary, high blood pressure. So, with your family members may have had, like your parents, siblings, the possibility that you could develop it as well. If you have an infection, if you have any poisons, can poison your body, cause disease. toxicity if you don't get the right nutrients, or you got some kind of imbalance going on in the body, and then some environmental factors. So unfavorable environmental factors are going to be you work at a place that I think it was like when I did travel therapy or in Albany, there was this patient that kept coming in with like breathing problems. He was like coughing up like black stuff, and I can't remember what else he had going on, but he worked at this, I think it was like a paper mill for like 30 years. So that is unfavorable environmental factor. So sometimes places that you work at, when you're in the same environment, breathing in such and such all the time, could be detrimental to like your health. So that's why it's important if you work at a job like that, that you're exposed to different type of environmental things, like you wear the proper PPE if they require you to, because it's for your protection.
We identify disease and illness by signs and symptoms. Signs of disease are objective, so they can be observed or measured, like fever, high blood pressure, or a rash. Just as you can see a sign on a city street, you can see signs of a disease. Symptoms are subjective, meaning they can't be observed by another person, but a person that is ill experiences them. Symptoms are experienced by a person with disease, such as dizziness, pain, or blurry vision.
So signs are things that I can measure. So I can take your blood pressure, I can take your temperature. Um, you know, Symptoms are what you feel. Like I don't know how you feel, but you can tell me, oh, I have a stomach ache or I have a headache. Like I can't look at you and tell that you have a stomach ache or a headache. I don't know that. I can look at you and say you don't look like you don't feel well, but you have to tell me what your symptoms are. So that's why it's important if you're having any kind of symptoms, when you do go to the doctor, you express what those symptoms are, because medicine is a practice. So you tell me your signs, and we'll take your temperature, blood pressure, all that stuff, your signs, and then your symptoms, and they'll go through a checklist of what this could possibly be to figure out what's going on with you.
Signs and symptoms are often confused, but now you know you can see signs of disease, but only an ill person experiences subjective symptoms. Diseases also negatively impact individuals, families, and society as a whole. Diseases can be both physically and emotionally problematic. Disease prevention and treatment is expensive and can negatively impact our society.
Keeping a state of balance in the body is known as what? Homeostasis. Body systems must work together in order to create homeostasis. This is called interoperability. Right, it's called interdependency. Disease is a disorder or what functioning organ, part, structure, or system of the body. Right.
When body systems are not functioning properly and homeostasis is not being maintained, this can create problems with the cells in the body. For example, trauma from an injury can affect cells in the body. Decreased blood flow and lack of oxygen may cause cells to die. Bacteria and viruses may also lead to cell death. Injured cells, instead of dying, may follow abnormal patterns of growth. Some forms of abnormal cell growth include atrophy, a decrease in size of cells as a result of aging or disease; hyperplasia, an increase in the number of cells; metaplasia, cells being replaced by another type of cell; dysplasia, cells changing in shape or organization; and neoplasia, cells changing in structure with an uncontrolled growth pattern.
Alright, what can create problems with cells in the body? Huh? Alright, so what goes with what? What's an increase in the number of cells? Hyperplasia, because hyper means like increase. Um, cells changing in structure with an uncontrolled growth pattern. Y'all should just guess. Who? Cells changing in shape or organization. Cells being replaced by another type of cell. Decrease in size of cells as a result of age or disease, atrophy. And we'll talk about atrophy when we talk about the muscular system. Alright, so you got these three wrong. Which way is 3 of them? Dysplasia for the shape here. So
Metaplasia for type of cell.
right. And what atrophy is?
Another problem that may occur in the body with abnormal cell growth is tumors. When cells
What atrophy is like, say you break your arm, you have a cast on for 6 weeks. Once you take that cast off, you know your this arm's gonna be a lot smaller than this arm, the arm that you've been using, and that's called atrophy. When it's like the wasting away of like the muscle because you're not using it. You know, even though you don't think, I mean, it's not working out, but you're using, you're picking up stuff. But if you got this cast that you can't move, you can't use those muscles, then it's gonna atrophy or waste away.
grow old, they should die and become replaced with new cells. Sometimes this process goes wrong. New cells form when your body does not need them, and old cells do not die when they should. When these extra cells form a mass, it is called a tumor or a neoplasm. Click each button to view more information about the two types of tumors.
Alright, so you got two types of tumors. You have benign and you have malignant.
Benign tumors are tumors that only grow in one place. They cannot spread or invade other parts of the body. However, they can be dangerous if they press on vital organs, such as your brain. If a benign tumor is causing issues, they are often removed with surgery and usually do not grow back.
More serious is spread.
Yeah. Benign, I mean, if it's pressing, so it's like in your brain and it's pressing on something, no, that's like the only way they're gonna remove it. I mean, if they can remove it, and if it's affecting something for benign, like here, it's like it's pressing on something in the brain, so they'll remove it. And then you have malignant, because remember, mal means what? What does mal mean?
Malignant tumors are also called cancer. This type of tumor crowds out healthy cells as it continues to grow. Nutrients are drawn away from other body tissues, which interferes with body functions. If the malignant tumors spread to other parts of the body, it is known as metastasis. There are more than 100 different types of cancer. Symptoms and treatment depend on the cancer type and how advanced it is. Treatment may include surgery, radiation and/or chemotherapy, and hormone therapy.
So malignant are the bad tumors. Mal means bad. What cancer is like an overgrowth of cells. So like here they have cells and you have this overgrowth here. And then like they don't respond well to like treatment and stuff. So it might do chemo, it might do radiation, it might give you some medicine to try to fix it. And if they can try to remove it. Now, so say for example, like I had an aunt that passed away from breast cancer. She had breast cancer. She had it 3 times. So the third time is, when she passed away. But so she had it in the breast, and then it spread to like liver, and it spread somewhere else. So that means it metastasized. So if you hear somebody say something metastasized, that's what it means, it spreads. So that's what that is. Lillian has a tumor in her lung that has metastasized and is beginning to invade her liver. I will treat her with surgery, chemotherapy, and radiation. Malignant. And then this one, Neil has a tumor in his neck. It will not spread, but I must keep watch to make sure it does not begin to cause pressure on any important nerves in the area. So I will remove it surgically. That's benign. So if you have like benign, like growths and stuff like that, they might not remove it unless it's like causing kind of damage. Like females will have these benign growths like in their breasts, like cysts, like breast cysts, or I keep forgetting the other one. But you know, that's a big thing as far as breast cancer. So they might watch it to make sure, but all right, we'll start talking about skeletal system on